All right, thank you everybody for joining in today of our first ever RJ Lang hosted event over here on Zoom. We went through the LinkedIn admission process, and that was an interesting process. It doesn't all talk very well to each other, so that was fun to navigate. But lo and behold, we are here, and our panel today is a mix of industry experts from really the facets that I see are pivotal in communicating amongst one another. That way we can move forward as a collective group and start installing the smart city lighting projects on a larger scale basis. First up, I have with us Cindy Brewbaker. She comes to us from Telensa. It's a smart streetlight control system where she is the national sales director out of North Carolina and is a lead ambassador, leadership in energy and environmental design. She has 20 years of experience in infrastructure maintenance management. She has spent her life creating strategies through innovation and technology. Cindy is a beacon of what it means to leverage existing assets and turn them into money savers and money makers. Her devotion to efficiency is apparent in the smart LED systems. By using one of the oldest, largest, and predictably spaced daily use assets, streetlights, Cindy has created a network of connected and intelligent roadway lighting practices, allowing business owners, public works directors, utility managers, asset owners to gain full visibility into the operations and how to add smart nodes to those assets and create a connected infrastructure for her clients. Also, Amanda Dixon from SCLC, Smart Efficient Lighting Controls, as the VP of Sales out of North Carolina. Amanda is accomplished in leading cross-functional teams to develop and launch products in the smart grid outdoor roadway lighting market over the last 15 years. Amanda has won the largest deals in smart city lighting in North America. She has strong relationships with utilities and municipal standards lighting engineers and extensive knowledge regarding trends in the lighting market. Awarded the Next Generation Award for ANSI Board of Directors in 2009 for leadership and vision in the work and support of standards for the roadway and area lighting. Amanda holds a BS Electrical Engineering degree with North Carolina State University at Raleigh, North Carolina. Also joining us today is Mark Carter. Mark Carter is from Real Term Energy out of Pownell Center, Maine. He's a VP of Smart Solutions. Mark has 30 years plus experience in controls, ranging from industrial automation, building automation, and lighting controls. He's currently responsible for product development and partnerships of Real Term Energy's MyTown Smart Solutions, which is targeted for small to mid-sized municipalities. He's a subject matter expert for smart lighting controls for Real Term Energy's LED lighting conversion services in the municipal and utility markets. He's also the co-instructor for Smart Controls training courses at IES, Street and Area Lighting Conference, as we know, SALC. As we see more advancements in the smart LED Connect lighting technology, we're certain to hear Mark's name in the mix. Coming to us from Stresscrete, Mitch Faskin, where he is a smart infrastructure guru. As an entrepreneurial-minded individual with an exceptional track record of success in academics and in the corporate world, he's currently working at Stresscrete's group, developing concrete and metal light pole solutions that hold 4G and 5G small cell antennas for national telecommunication carriers and North America's largest utility groups. Mitch holds an MBA at the DeGroote School of Business, where he was president of DeGroote's Entrepreneur Club and president of Dan Management Student Association. And last but not least, Keith Tyson from Ubiquia. He's a Northeast sales manager out of Buffalo, New York. Keith has been in the boots on the ground, working directly with municipalities to convert HID to LED and adding smart control nodes. Keith has shared in successfully launching many smart LED programs and understands we are at just the beginning of the smart city. Sorry about that. We are just beginning this journey to connected smart cities. Not only is he effective at smart LED programs, he is assisting in modernizing the grid by leveraging Ubiquia's tech. Thank you all of our panel members for joining us today. For those of you out in the audience, we are giving away the DoorDash gift card. So if you could locate in the middle of your screen the chat box, what I'd like you to do is inside of that chat, all I need you to do is guess a number between 1 and 100, put your name, phone number, or email that you'd like us to use so you can claim your gift card. We'll let you know when those numbers are chosen. I chose them through a random generator this morning, so there's no cheating here. They're already picked. And so we did a random order for you guys, and the order of the panel is going to be Cindy, Amanda, Mark, Mitch, then Keith. Okay. And we've given you the 5 questions that have been coming through pretty often from my experience, and I'm going to leave it off to you. Cindy, go for it. Go ahead and share.
All right, are you able to see my screen? Are you able to see my screen? Okay.
Yes.
Everyone was muted. Good. So, just this is not about Telensa. This is about how we really adjust the industry to include smart control nodes with LED conversions. I almost feel like, this panel has got a really good mix, because I almost feel like we don't even need to justify why we have to do the LED conversions, because that cost savings is pretty clear. That business case is there. Then why are we also wanting to make those same assets into smart lighting? So, I think one of the questions was, what do you know what a node is? So I just want to talk a little bit about, how we envision that end-to-end solution. So every single light would get what we call a node. That's sort of an industry standard term. Then those nodes connect back through gateways. And then all of that gateway data is then fed to the cloud to, just generically speaking, a central management system. And that central management system serves as the brain of the operation. And that's where all of the real smart activities and programming can occur. So, how do these things happen? So we'll let someone else talk about maybe like the cellular option. One of the ways that you can also create this connection is through a private network, and we use what's called ultra narrowband technology. That ultra narrowband, or UNB, really just creates a private network versus sometimes you would consider a cellular network a public network. And so I know that someone else will talk about that. And then those base stations or gateways feed up to the cloud, and it's really creates an environment where you can then put other smart city applications on it. So why would you do this? One, you're investing in smart technology from the lighting. You need to have visibility into that asset, and that really helps with being able to reduce truck rolls. Just full. You don't want customers to have to, your customers, the citizens, to have to call to report outages. You want to be able to see all of these things. So speaking in a very basic manner, but why would you want to put up an expensive new LED but not have visibility into how that system actually operates? The low-hanging fruit really for why to do this is maintenance savings. Just for kind of a comparison, the company that I represent is based in the UK. And when you look at some of the IoT and smart city devices that are coming out of the UK and Europe, there has been a considerable higher degree of adoption. That also kind of plays back into, where do we see the industry in 3 to 5 years, and then longer term into 10 years? We truly believe that that's one of the things in North America that we're going to see, is just a higher adoption of smart lighting. At this point in the UK, it's close to 40% of all of their LED lights have smart nodes on them. In the US, that's single digits. So part of this, so why is it that there's adoption in other places? Part of that, one of the barriers to entry, I'm sort of, combining a lot of Ron's questions into one, but some of those barriers to entry are, one, the utilities do not always allow time of use tariffs. And so some of that from a regulatory standpoint, we're seeing some evolution there, that when the customers own their own lighting, they can then perhaps they can use that time of use tariff for more accurate billing. A second barrier to entry, and I'm sure that Mark could expand on this, is financing. But these systems really have the ability to pay for themselves in energy and in operational savings. So there are mechanisms in place through guaranteed energy savings projects where that can happen. So I think once you hear all of the solutions and tied together in the way that the different panelists are approaching the same questions, I think that then you're going to see why, as an industry, we really need to be promoting the intelligent lighting with the energy savings LEDs, and how cities in particular can bring that project together. So I'm going to then go back, I think, to Ron, and you'll see who's next. And then happy to answer questions after you hear some other variations of the same type of approach.
Awesome. Absolutely awesome. Thank you so
I
much,
didn't take
Cindy.
the whole 10 minutes, so.
Yeah, that was fantastic. Fantastic. And I like how you combined everything together. The time of use tariff is something that I've been hearing a lot more of lately, and I'm interested to hear what the rest of the panel has to say about that. I'm sure it's going to be a recurring theme, given the amount of times I keep hearing about it. So, Amanda, I'm going to leave it off to you.
Thank you. I'm going to share my screen as well. And I'm going to say, you say this is random, but in regards to, I think you did ladies first, and I appreciate that. I'll take it any day of the week.
It was supposed to be subtle.
I appreciate it. I'm going to elaborate on a lot of what Cindy said. And actually, you can tell this is so ad hoc because she's saying so many things that I would say that now I'm going to weave and try not to repeat her, but maybe enhance some of the wonderful things that she said. And I appreciate that. Cindy, you starting out. Like you said, this is the age of connectivity. You're probably even getting phone calls like I do from my grandmother asking me, how to, do Netflix on her smart TV. And how to use her cell phone. And so, we have come into an era of instant connectivity. I started in this area in 2005 in regards to street lighting. And it has made a huge change in leaps in regards to how we look at streetlights today as we did back then. And, now we're seeing the opportunity, especially municipalities and even utilities, that there is a value in the asset of a streetlight. It is an opportunity. It has a power source. It can be way more of a connected system to support customers and solutions and things to the atmosphere of a city or an ecosystem. So it's an opportunity. It's kind of a skeletal backbone to a lot of opportunity. And so we're trying to still, it was back in 2005 and 6, I saw a lot of utilities selling those assets off to cities and vice versa, cities, because nobody know what to do with that. And today, I think it's finally getting out there that there is something there to hold on to and something to show. As Cindy mentioned, LED adoption has taken off. Everyone sees the value of an LED fixture in regards to efficiency and energy. And this is just from the Northeast group showing that in 2019, it's about 45% adoption rate. And our controls, the smart controls, is around 10% right now. And we believe that this is going to grow extensively over the next couple of years as we educate and influence the environment to show that there's so much more that they can do. It's like having, an LED out there standing alone on a photo cell is like having a TV, that is of the old system, in regards to you'll never know maintenance, you never have an opportunity to, connect to the systems out there in the world. So there is that infrastructure that could be added in to do so much more and to leverage what you call smart lighting in regards to a control on the end of a street light, feeding back in through a network and a system. Today, a lot of the opportunities that we have won is with customers who realize they already have an existing network, an AMI network, whether it's here with what I'm showing with Itron, or with our other partner Census, they have a network with either doing gas, water, electric that they're now going to leverage with the lighting. So the, already existing reliability and quality they have with their network, they're now going to get with feedback on their street light. I mean, a street light is something where you're going to be feeding back power, voltage, current, power factor. A lot of information can be given through a street light, but it's low level information that doesn't require, an extensive amount of network to support in regards to the feedback of the information, because it's very low bandwidth. So it's an opportunity to provide their, opportunity to give to Streetlight all that information. And then can you do so much more with it is the question. This is also from the Northeast group, just adding smart controls to LED fixtures can have a return on investment of $200 on average per light. And there's even more value if you think about implementing things that a lot of customers don't know, and that's constant lumen output, where you can get significant additional energy savings and maybe not even see a lumen change over time. That's a lot of things that a lot of customers don't think about. And we also influence the city of Chicago to do something very similar, where they dim 80% so that they can get savings. So not only over the 10 years, we're also going to extend the life of their assets beyond that by doing that dimming and that support. So that's what smart controls can do for just your independent street lights out there. So just as Cindy said earlier, I mean, you can get just a return on savings, a low hanging fruit of energy savings, and even what she mentioned, operational savings in regards to maintenance and truck rolls and supporting your inventory levels in distribution and reducing any cost, customer complaints. You'll get all of that with smart lighting as well. And always the next question is what can we do more? Everybody wants to hear about smart cities and what other infrastructure can go onto a street light. And the point is that a network can give you the opportunity to do so much more. I mean, I think a lot of cities and utilities probably have existing networks out there they can think about and how they leverage. Do they integrate using, the street light to send information along as well? As a possibility, or do they strap on opportunities for routers and power taps and other things to send back information? You need to think about the value of your network and what you want, to be the backbone of this infrastructure. You had also asked the question, what are the next steps, things, the way to integrate, and what are like the hurdles? We have had out there in the terminology, I've sat on the ANSI C136 committee since 2006, and we have integrated, and implemented a 7-pin solution onto a network lighting system. The pins 6 and 7 have never been specified to date. We leave today and we're about to publish a table that has 24 opportunities. It's almost as many basket ice cream toppings and flavors out there in regards to information you can get back. So it's really important for cities and utilities to think about what applications they want out there and how they want the information to come back, so that the firmware, the information that's out there is supported. We'll make sure there's value there in the information and the alarms, what is out there. Also, the second thing you had mentioned too, Cindy had mentioned, is that tariff. I have talked to so many public utility commissions. I happen to sit as the working writer for ANSI C136.50, which is the standard for metrology for the street light. We adapted ANSI C12.1 and 12.20 for electric meters, and we moved it into the format of a street light and what that looks like. That standard is planned to be hopefully published before the end of this year. And that is, fingers crossed, it's going to committee for ballot later this spring. But as we wait for that, and as I've actually gone and talked to a lot of PUCs, the concern was how do they, have something out there they can point to make sure that things are qualifying to be the reliable metrology that they say, so that, utilities and cities can have something to lean in on to make sure, that they're getting their information right and for the customers and things that they can do. So standards coming up to date has been somewhat of a barrier for that, so that, you know, these PUCs can feel like they can have something to point to as a requirement for those tariffs. And then, you know, of course, what I just mentioned, knowing 7-pin and how you want to integrate sensors into your system, to me is also something that needs to be thought through. And hopefully we'll have questions in regards to that we can peel through and talk about how, you know, how we integrate these things. All right, I'll send it back to you.
Fantastic. Thank you, Amanda.
Mm-hmm.
Absolutely. It's interesting to hear what you're working on from the metrology standpoint and with the 7-pin. And I do have a question later on about the coveted 10-pin I'm hearing about. So it seems like things are outpacing paperwork. But all right, let's move on to Mark. Thank you.
Thanks, Ron. Let me share my screen. I'll apologize in advance if I cover any of the topics that Amanda and Cindy already discussed. Do you see my screen, Ron?
I do not. It's coming up now. Yep, we're good.
So I guess real-time energy from this panel's perspective is a little bit different. We're not a manufacturer. So as an ESCO, we're actually deploying these smart controls in the field. And just from a historical standpoint, you know, we've been installing LEDs now since 2013. And early on in the adoption, you know, before the 7-pin came out, most of our projects were all just straight photocells. And I don't think it was until 2017 that we put our first smart control. And since then, we've deployed about 50 to 60,000 smart controls. So from a market perspective, we've seen a huge shift, and roughly about 70% of the lights that we install today have controls. So the adoption rate has gone up significantly, and I think it will continue to do so, you know, both as the costs come down and people realize the benefits of smart controls. So we have over 300 municipal clients. We put up about 350,000 LED lights, and we are a Department of Energy qualified ESCO. So that's a little bit of background. And we've also had the opportunity to deploy a number of different types of controls. So we've deployed 5 different manufacturers of varying types. So RF meshing in the 900 megahertz range for AMI type networks such as Silver Spring or Honeywell Elster. We've also deployed a number of 2.4 gigahertz RF meshing based systems, and we've also deployed some LTE based systems. So we've had a chance to kind of see the different technologies. There's different pros and cons depending on, you know, what your town or city looks like from a geography standpoint and a density of light standpoint. So this kind of covers what Cindy talked about originally, but RF systems tend to be kind of a 3-tier system where you have different types of controllers, and most of the controllers are, you know, have a lot of commonality, right? So think of a car. Every car has an engine and doors, but they may have different features above and beyond. So most of the controllers you'll find that will have a photocell that will default if they're not communicating, so the light will continue to work. It'll have some metering built in, a relay to turn the light on and off. A lot of those are common in all the controllers. But from manufacturer to manufacturer, we'll see that they may take use of, let's say, pin 6 and 7 to provide some sort of added functionality. So if they want to put a dial communication or a digital input or a analog input, they can actually connect to other sensors that may be on the pole and provide that information up into the cloud. And this goes through a gateway, and the gateway back up to a central management system. It's and really the only difference between that and an LTE-based system is that you just get rid of the gateway. So now everyone has a SIM card, just like your cell phone. That node is talking directly back up into the cloud, and then typically into some sort of cloud-based platform that's on Amazon Web Services or Microsoft Azure, typically. And there's all different types of user interfaces that you can find from manufacturer. But in most cases, they have a lot of commonality insofar as it allows you to monitor your assets. It allows you to control and schedule them. So if you want to take a group of lights and you want to put them on a dusk to dawn schedule, or if you want to dim them down at at midnight or 10 o'clock at night, that's generally the what's included as part of that whole smart control package. And what we see from a benefits, because we're working directly with the end users, the cities and the towns, I'd say the two biggest benefits, and one has been mentioned before, the maintenance. So now you can actually monitor and know when your light is out ahead of time, so you can get out there and repair that. A lot of times even before a resident calls it in. But there's also from a from a political standpoint, to be able to address any resident complaints. Even as yesterday, I was working with a town that had smart controls, and it's actually managed by the police department. And they called me and said there was a resident complaining, and they were able to dim that light down. So without having to wait to get a bucket truck out there, having that smart controls allow you to be much more reactive to any sort of resident concerns. But much like we've seen the transition from straight LED lights to LED lights with smart controls, where we're really seeing the market at this point is adding the smart city applications. And this is just kind of a sampling of different technologies out there that will plug directly into a street light that provides some sort of processing platform that now you can connect to other devices. So if you have air quality sensors, if you have sewer wastewater level sensors, if you have road temperature sensors to know when you want to go out and sand and salt roads, you'll see these technologies all connect directly into an LED street light. So really today, what we're seeing now is a more of a shift toward, smart controls is almost a given. And now they want to move on to the next step to say, do I want private LTE? Do I want to put CBRS or public Wi-Fi? Do I want to monitor air quality around my schools? Because, typically air quality has a big effect on those that from an absenteeism rate is a big influencer. So there's a lot of different technologies and sensors that you can integrate in these platforms. And that's really where we kind of see the industry moving toward. And I guess one of the questions you also mentioned was, what was one of the biggest hurdles? And I think it was mentioned before, it really is ownership. You go from state to state, there are different rules in regards to, does a municipality have the right to request their lights and buy them back from the utility? So some states they do, and some states they don't. And that's where we find the biggest hurdle. It's typically not a payback, because these are generally cash flow positive projects with ROIs in the 3 to 4 year range. So it's it's typically not the financial side; it's more and more the ownership side. So with that, I'm going to turn it back over to you, Ronald.
Awesome. Thank you so much. Appreciate that, Mark. Those were a lot of great points. I never even thought about the air quality controls around schools and how that could have such a drastic impact. That's definitely food for thought. All right, moving on. Keith, you're up.
Now, are you able to
There you
see? Okay, great. Yeah, I think to some of you, you may not be aware of who we are. And so I wanted to just, there we go, that's better. Just a little bit about us. A lot of what's been said is great. And we all, as I think Cindy said earlier, we don't have to sit here and convince each other of why smart controls are needed for the system. And just from our perspective, from what Ubiquity has done, and I'm going to share my time with Charlie here, who I want to introduce him as well. He's the VP of our utility sector. And as we were discussing this prior to the call, there's a couple things that I think have made the whole idea of smart and connected streetlights for us a really incredible conversation. One of the things that we see is, not only is the smart and connected streetlights a win for the municipalities, it's also a win for the utilities. And we have developed a world-class board of people that have come from both the utility and the telecom industry because of that. And we've got utilities that have invested in the company because of the desire to see technology that we've produced help them in various assets, assets of their system, whether it's lighting or even beyond lighting. And I think if we were to look at what a smart and connected city looks like, there's a number of different things that have already been talked about here, right? We've talked a lot about light control, and I think there's three main areas that you can have a conversation like this around. One is smart lighting, and then also smart city capabilities, which Mark just talked about as it comes with smart lighting. But there are other things that you can do with a streetlight system now. And Amanda, I think you mentioned earlier, and I'm very well aware of in the 90s up in the Northeast here, a struggling utility that sold off all its assets to the municipalities. I think as the story goes, they may have sold it for $1 a piece to these municipalities. And now these municipalities are sitting on gold mines and they don't even know it, or they're starting to figure it out of what that might look like for them, of what they can do with their system. And so smart and connected lighting and smart city applications, utility-centric things that can be done through for a utility that is still maintains and owns the street lighting and is not going to be selling it off to the municipalities. And then the advanced, so I guess smart lighting, smart utilities, and then the advanced smart city applications. And this slide just kind of helps us, quantify and define where those applications and where those wins are for either the utility or the municipality. Being able to control the lights and all of the benefits that come with it, utilizing the streetlight network because of its ability to have persistent power to it, even spacing, typically runs and rights of way where you will get the typical runs of fiber and things like that a streetlight system has. And it's one of the few infrastructures that covers an entire municipality. And so it lends itself to be able to do things for a municipality or for utility through applications of controls that may not have been able to ever been done before. And from a smart city perspective, the nodes, the capabilities of the nodes to do things related to light control, dimming and scheduling, grouping, so that a municipality can understand what it wants to do with its lights. Maybe it wants to do something different with its lights in the parks than it does on the main roadways. And these types of things all are now available for a municipality to have a more user-friendly system, as well as the ability to manage the asset. And I think a lot of what these municipalities are, have to have a conversation around is, once I own the asset that I've never owned before, how am I going to manage it? And that same question is a question that the utilities can ask, but they're asking it from a bit of a different perspective. I've owned this system for years and years and years, and I don't have insight into what is happening in my system. How can I better manage this asset that I've currently owned so that I provide a better customer experience and everything that goes along with that, because the ratepayers are paying for it. And I think, Mark, you mentioned earlier some of the barriers to entry. I think in some areas, and again, this is different in different parts of the country, barriers to entry are whether the utility itself wants to maintain control of its system, or whether it is going to be open to letting the municipality buy it from them. Different municipalities are falling on different sides of that. Different states are, and so are different public service commissions. But it is certainly a major conversation of once, who owns the system, how are you going to manage it, and then what can you do with it outside of just managing it. And I think from this perspective, Charlie, I'm going to turn it over to you, because I think this sets up nicely for what you can address in terms of what can you do with a system once you have it. You've got the ability to do these other things, and also the type of structure that you're going to use, whether it's going to be a mesh-based system or an LTE-based system. What we've seen, and if you go back to this slide earlier, is that the LTE control nodes are becoming a greater and greater part of the conversation in the industry, partly because the data rates have dropped so drastically. And then the ability for it to cover multiple different areas and have be able to handle what is going to be coming in terms of smart city and other pole applications down the road. So Charlie, why don't I just turn the rest over to you to talk about that end of it, and also how this type of technology, control nodes, whether it's any different manufacturer, how it can actually help a utility.
Sure. So, as we look at the smart lighting solutions, and I've been in the smart lighting space, and before that I was with the utility for many years right here in Raleigh, Progress Energy, and I ran the metering group. So my background is utilities, AMI systems, electric, gas, and water networks at Census. And so what I began to see a few years ago is this trend towards using the LTE networks. And for lots of reasons, I've seen 3 different areas grow within this smart lighting solution. Of course, there's the core lighting control, scheduling, dimming, alarming, et cetera. That will always be there for smart lighting. But what I also began to see are some utilities, whether it be a co-op, a municipal utility, or an IOU, asking, so what's in it for me? It's, as we go to LED lights, change tariffs, it's actually revenue erosion for the providers of electricity. So what's in it for me? What benefits do the utility see for smart lighting? And then there's the smart city benefits. So this 3-legged stool here, and the area of growth that I've seen a lot in recently is the utility space. The utilities have been on the sidelines. They're realizing now, maybe we should not sell the assets to the cities. Maybe we actually could benefit from them. And some of the features that I'm seeing them use now is, for instance, outage detection. Most of the solutions on the market can detect when there's no more power to the fixture. And they can let either the utility or the city or whomever owns the lights know there's no more power here. It's an outage detection. But what the utilities care a lot about are what's called momentaries. These are brief interruptions that we're probably going to get here in a few minutes with this wind, where devices called reclosers are, your limbs fall across a line in heavy wind, and the recloser essentially tries to burn off that limb or burn off that squirrel or a bird or snake, and not have to send the truck. The problem is that when it happens, our lights flicker, we're affected, utility has no clue what happened. So they're looking at lighting control devices down circuit of reclosers, which they have tens of thousands of, that could detect momentaries. One utility told me that if a recloser operates 4 times in a year, they've got to provide a report to the PUC that it happened. They have no clue it happens. Those reclosers do not have a comms layer. So now getting other rich data around sags and swells of voltage, and whether that means they need to cut in a capacitor bank to provide voltage support or boost the voltage. So the very utility-centric needs, stray voltage detection in cities where children and animals every year are shocked or hurt by leaning against a metal streetlight pole, and there's been some issue with stray voltage being applied into the pole. So utilities are seeing other things they can get out of these devices. And then on the smart city side, some of the solutions, don't mind that phone in the background that's ringing. I'm probably the only person that can hear that. And by the way, 2 of my grandkids will be here in a minute. So if you hear 2 kids in the background, ignore them completely, because I'm going to. So, and then the smart city features. Some of the smart city features are the ability to do what's called MAC sniffing. Can you anonymously detect people that have a laptop, tablet, cell phone walking by your pole, and use that for economic development, knowing how many people are in this area from 7 to 8 a.m. Should we put a Panera on this corner? Beaconing, push notifications. Some cities are looking at using the streetlight node as a way to put a push notification out, which is called a beacon, to anyone that comes within 50 feet of the pole to tell them, its curfew starts at 10 p.m. tonight, or this COVID testing site you're looking at in the Walmart parking lot closes at 10 p.m. or other localized public address announcements. So the trend I see is utility operations and utility benefits, the core smart city benefits, smart lighting benefits that we've been talking about, and now other smart city benefits. And then this challenges the network.
We have 1 minute.
Good. The second trend then I see is if you're going to do all those things in the smart lighting node, can you really afford to use an AMI network for that, which is bespoke for meter reading? And many of the utilities are kicking lighting control systems off because they're just using too much bandwidth, and hence the LTE networks, which range from NB-IoT, Cat-M, Cat-1. And so we're seeing a lot more push towards using existing carrier networks to support these lighting control solutions. And so that's the kind of two trends I'm seeing in the marketplace. And I'll just pause there.
I hope you guys were writing all that down because I know I was.
I was talking fast like a true Southerner.
That was great. I appreciate all the insights. And I had inklings about push notifications being a part of this strategy because retailers are using that more and more often that I'm seeing because I'm a part of some of those couponing or whatever, whenever they have a sale going on that they're pushing notifications. So
you're again, a couponer. Oh, okay.
Yeah.
I don't know if I told that.
Because we're always out there. Extreme couponing. That's it. Hey, thank you so much, Charlie and Keith. Appreciate you guys on that one. And let's move it on to Mitch and Adam over at Stress Creek.
All right. Hopefully everyone's able to hear me. We're just using our smart board there, and it decided to completely die on us. So, once again, technology, even if it has the word smart in it, sometimes isn't too smart. I think what will be really interesting is talking about like Stress Creek Group itself. I feel like our angle in this whole thing is a little different than most of the panelists, and that's because of who we are as a company. We're a family-owned company that's been around since 1953, and we're one of North America's largest manufacturers of pre-stressed concrete poles, street lighting poles, metal poles, as well as decorative LED light fixtures and the decorative arms to hold those LED light fixtures. So, to us, smart LED lighting really means, making sure our LED decorative fixtures are able to hold any kind of smart node. We try to be agnostic between all the manufacturers, and that allows, the cities or the powers that be to select the node that they're looking for. And make sure that it works with our light infrastructure. And really for us, we don't focus just on the light. We also look at how does the whole pole structure become smart? Because really at the end of the day, especially as we see the growth of 5G networks, the pole asset itself is a very valuable asset when you can start integrating other bits of technology. One of the things I've been working on a lot is the integration of small cell technology with a lot of the large telecommunications carriers, but also things that we've been working on, such as integrating electric vehicle chargers into the pole structure itself. And that opens up a whole new world of opportunity. And I think that really is kind of we've seen this move forward because of the growth of 5G networks. And if we look at 4G, for example, some of the changes that came about in the economy because of that. Now the largest taxi company in the world doesn't own any taxis, looking at Uber. Largest hotel company in the world doesn't own any properties, really, when we look at Airbnb. And all that was because of 4G networks. That's with the growth of smartphones. And so now when we look at 5G, which is going to be, hundreds of times faster, you can download a full 2-hour HD movie in 3 seconds is what they're estimating, is that it unleashes a whole bunch of new possibilities, whether it's, obviously now work from home is the go-to on that, but the democratization of education for people that might not be able to go to the classroom, but they can do something from a connected device, or there's so many unlimited opportunities with these networks. And where our company fits in is making sure that our pole structures that we've been designing since 1953 and our LED light fixtures are able to integrate whatever the technology partners want to integrate. When we look at really some of the low-hanging fruit here for revenue generation, obviously we talked about the go-to is obviously cost savings we've seen from any LED conversion projects we work on. obviously using a lot less energy, the lower maintenance, lower overall cost. But for us, we look at, making use of the full pole structure, making it a smart pole. That's what we've seen a lot of utilities in the telecommunications carriers working together to come up, whether it's a pole ownership, and that's where that big pole ownership kind of discussion comes out of, is who owns what. Is there going to be a lease agreement that we've seen on each project we've worked on? It's kind of changing each time, which makes it a little tricky for us at times to stay on top of it. But it's been a very, very exciting time for us as a company, because there's so many opportunities now of something that, we've made for a long time, and now seeing, all right, there's now so many more opportunities of what we can do at the pole to help our customers get the most out of that asset. Some of the biggest hurdles we've seen, and I've seen this more on the telecommunications side, so not necessarily on like the smart node side, but when we look at even building out small cell networks, some of the biggest hurdles come from not having the crews to be in the human resources to be able to install them. And when we think about that, when we start looking at the large scale deployment of 5G and using small cell antennas, a lot of the companies that we work with, they've never dealt with streetlights before, and they're like, all right, so you guys are the pole experts, help us out here. How do we install this even in the ground? And so making sure that crews know how to do that, but also that they are trained safely and trained on how to do this properly, so that these crews not only are getting it done and making sure everything works, but they're doing so that they're safe as well. Another hurdle that we've seen a lot of times is making sure that all parties in these kind of transactions are working together, and working in everyone's best interest, because with everyone working together, everyone's able to move forward. But whether it's the cities or municipalities, the utilities, our telecom partners, infrastructure partners, they all really do need to make sure to work together on this. And we've run into projects on that one of the parties or the other chooses to disagree, but that's where Stress Group as a company has been. We've been dealing with street lighting. We're street lighting experts, not just the lights, but the poles as well. And that's where we're able to kind of bring everyone together and say, all right, let's come up with a solution that works for everyone. The municipality is going to get their fair share of it. The telecom is going to get their access to the pole infrastructure that they need to build out their network. And the end result is the consumer wins. And that's because they get their network built out. They're able to do so much more. And when we look at the idea of a smart city, how attractive it is for new businesses or for new residents, that's tax revenue there for cities as well. Really kind of wrapping up, because I didn't want to take too much time. If people have questions, that way everyone has a fair share of time. One thing that we've really seen over the next couple of years, I've talked to a lot of telecommunications companies that have asked us about the full integrated pole solution, and everyone gives me a different answer, but I've heard they'll say 1 from every 9 poles they'd want to see be smart in terms of having telecommunications infrastructure or EV infrastructure. I've also heard the number of 1 of every 3. So what that tells us is that a lot of the existing pole structures out there, there's a good chance that either they're going to have to be slightly replaced, but that replacement cost is offset once again by revenue generation through telecom lease agreements, through EV charging infrastructure revenue. There's a lot of opportunity there, and it's just our goal as a company, and I'll wrap up with this, is to help everyone enhance their communities that we're serving. Our company, as a family company, we're big about serving our communities with integrity and respect, and with that, it's enhancing the communities with our infrastructure, with our poles, with our lights, making sure they're integrated with smart nodes. So that's all I have. Hopefully I didn't ramble for too long. And yeah.
No, you did great. That's fantastic. I knew that you would come with a different perspective because you have more of the 4G, 5G background, and getting an understanding of that is utmost importance. And I liked what you said too about how many advancements that we've made as a collective culture with 4G, and how that's going to exponentially increase with the introduction of 5G on a larger scale. So I appreciate that insight. Thank you, Mitch. We do have a question that came in. What is the benefit of using Dolly? I'm going to just open it up to the panel, so feel free to chime in as you see fit.
I'll jump in there. The obvious reasons are, and of course, Amanda Cindy know this very well. I'm very familiar with Dolly. It's a European standard. It was invented for interior lights. It's moving outside. It's moving to North America like the Beatles. And what we see is not just for a more finely tuned control of dimming for dimmable fixtures, but there's a lot of other information that could come from a driver, from an LED driver, that can be then presented to the node. There's asset data that can be pulled directly from the node, from the driver, that can be presented to the node and backhauled for asset management. But one of the things someone mentioned about air quality, and in that slide that we showed, this island slide, there was an air quality sensor. We're actually placing air quality sensors on poles and bringing 2 wires up to pin 6 and 7. And so Dolly enables us to both power the air quality sensor and backhaul its data. So most sensors, people are looking at RF means, and there can be more money tied up in the modems and the power provisioning for the sensors than the sensor itself. In our case, we're actually leveraging Dolly as a way to power and backhaul the data for this air quality sensor with a 2-wire connection. So
how does that work as becoming a power source, though? Does that
Dolly is a digital bus that also can provide power. So power over the 2-wire interface. So it both powers the sensor, communicates from the UV cell or the node to the sensor, and then uses the LTE to backhaul the data from the sensor. And it's just a convenient way to leverage the node as a nice backhaul. So you take 2 key functions out of the cost of the sensor, the need to provision power to it and have a power attachment, and or a modem if it's RF, and those 2 things go away. So it's one method.
And let me add a little bit on to what Charlie was saying about Dolly, because first off, I do want to say what he's mentioning to you. Dolly has different versions. It's a standard 2 that gets updated. There's a version 1, there's a version 2, and there's even one that's been adapted for D4I drivers, for LED drivers that have a new script in regards to a modified Dolly. So you need to make sure that you understand when you choose a system, that you know which one of these communications. Does it support one? Does it support all? And the mentioning that he mentioned about the power, I mean, that is on one version of that. So you need to make sure that you understand the whole ecosystem of what you're asking for. And one thing, great about Dolly, as he mentioned about in regards to asset collection and other things, is that, you can actually use Dolly through pins 4 and 5, and you can send dimming commands, but you can also send other sensor quality information through, if you speak Dolly, you can use pin 4 and 5 to do that too, because you can write comms, you can write to different registers. So you don't have to have 7 pins. If you have pins 4 and 5 there, you can communicate Dolly through that as well. So just wanted to add that.
Ron, I mean, both of those were sort of more technical answers. Mine's a little bit more practical or application answer. Is all of the all of the smart node systems that we've described all feed back to a central database. And that central management system can sort of serve not only for lighting type information, but also kind of a pseudo asset management platform. And you can collect some of that fixture data directly from that driver, and it will populate the lighting management system as well. So you don't have to have the same, you can have one system of record if it can read that information directly, and then you don't have to, I mean, you'd be surprised. I mean, we're talking about how many people don't have a smart lighting system. You'd be surprised at how many people don't have a really sophisticated asset management system as well. So it sort of combines 2 into 1.
Awesome. Thank you guys for that. We had another question come in. Mark, I think this one's directed at you. Private Wi-Fi, are you seeing that more for concert stadiums, events, or business districts? I guess their question is, where are you seeing those applications at?
Where we're seeing, and it's the citizen band radio system, right? CBRS, and it allows, it could be used for private venues like arenas and such, but on a municipal side, there's nothing stopping a city from standing up their own LTE network. And there's a lot of benefits to doing that. One is there's a lot of LTE-based devices that they could leverage versus going to a major carrier like AT&T or Verizon. So think of parking meters. You see a lot of parking meters now that are cellular-based. even lighting control nodes. And there's going to be other devices as 5G starts to get rolled out in a larger fashion. So as sensor costs come down, instead of actually leveraging a carrier, they could have their own. And it certainly has a lot of benefits from in-home learning for schools. It's a much better way to manage the devices that are on the network. So school departments could issue USB dongles, they could do MiFis, and those would actually have SIM cards that would be tied to the municipality's LTE network, as opposed to paying a $40, $50 a month per MiFi charge for schools. So there's a lot of different use cases, and there's a lot of cities out there that actually own fiber that could allow them to stand up their own network.
Thank you, Mark. One other question we have: what are the different communication frequencies? You mentioned a couple different gigahertz, megahertz. What are the differences between those, and where do you see as an optimal solution?
We deployed a number. I mean, really, the biggest difference is as you decrease your frequency, you lose some of your bandwidth. You tend to gain on distance. So 900 as a rule of thumb, and your radio power output certainly has an impact on that as well. But generally, you would see a 900 megahertz would have a greater range than a 2.4 gigahertz. But I think based on what information you're pulling back and on the pull rates, if you're doing every hour, both are more than suitable for pulling back the information of what a controller provides. Your status, any alarms, your voltage, current, power factor, all that information that's encapsulated. I don't think there's any bandwidth restriction. So some are unlicensed frequencies, some are licensed frequencies, and there's certainly some benefits there as well.
Amanda, do you want to add in onto that?
Yeah, I mean, Mark, you did a great job answering that. I think, I would just add that, one of the questions, the last one you asked is, where is things going in 5 to 10 years? And to me, there's not a frequency that rules them all. This is not another network or solution that rules them all. I feel like in the big scheme of things, you're going to think about your applications and you're going to say, hey, I need high bandwidth speed for this, and I'm going to use this frequency to modify this area. And then you're going to have other networks that are going to be your low end, that are going to, handle your day-to-day infrastructure of just turning on and off of a fixture. I mean, so to me, the leverage of thinking, if I was a city or a utility, I'd be thinking about what solution am I doing that can integrate the value of all of these opportunities and leveraging those. There's benefits of all of them, is what I'm saying.
And that's what it almost seems is, depending on the layout of your city, and there was a light density was also another factor that somebody had brought up. Depending on those factors, it could really push you in one direction or the other, because you may need longer distance reach and less distance reach, but more saturation. So I can understand that.
That's the key difference between a co-op, a muni, and an IOU. I mean, co-ops are very rural, and there's a lot more spread out, and it challenges and it informs the type of network you have to build to reach disparate devices over a very rural area. In a muni, things are tight. There's a lot of density, but there are also buildings and trees and things you've got to get around. And to further complicate the whole spectrum thing, the higher frequencies tend to bounce off of things. The lower frequencies tend to go through things. And if you don't believe that, have one child of yours in a horn instrument and one playing the drums or the bass guitar. The bass guitar goes through the house. You have to go in the yard to get away from it. But the horn, you could put them in the garage and you could still read. It's different frequencies. They go through walls or they don't. So
that illustration is perfect. I get it. I totally get it. Well, hey, we're actually over the 1 o'clock mark. So I want to go ahead and shut this down. I appreciate everybody joining in. If you could, I have the numbers for the DoorDash, and I'll be sending out those gift cards to you. The numbers were 70, 15, 42, and 94. So if you think you were close, stay close to me. But I have everybody's guesses here. and I'll get that out to you.
And if those are lottery numbers, we're all splitting this, right?
Of course. Yes,
Okay.
everybody bought in, right?
I
Everybody
just
bought
took a
in.
screenshot.
Yeah.
Don't worry. I took a screenshot.
I take Cash App, I take Venmo, and PayPal. So however you'd like
Okay.
to.
Fantastic.
Thank you guys so much for joining in. This was recorded, so if you do want to, if you end up sharing the event and you want the recording, I'm happy to provide that for you through Dropbox link. Thank you
Great, Ron.
guys.
Thanks for setting it up.
Yeah, no problem. Have a great day. It was great
Take
connecting
care,
with those
folks.
of you who I didn't know, and looking forward to it.
Thanks for having us.
Great. Thank you.
Bye-bye.
Bye.